Observing an individual's phenotype. So phenotype is what it looks like. It's what its physical appearance is. That's how I always remember phenotype, because phenotype begins with a P and physical appearance begins with a P. So observing what an individual's physical appearance looks like is not sufficient to figure out what the genotype is or what the genes are in the background. And that's why sometimes we have these genes that pop up out of nowhere that are surprising. When I used to teach in Texas, I had a student who, you know, a lot of the students down there, brown hair, brown eyes, because they're of Hispanic origin. I had a student who had bright green eyes. And so he had that green-eyed characteristic kind of lurking around in the background. And it wasn't until he was born that that recessive characteristic managed to come out. And so looking at someone and looking at what their physical appearance looks like doesn't mean you can tell, are they homozygous dominant, are they heterozygous? Usually you can tell, though, if somebody's got those recessive genes, because of the recessive, there's no way it could have come out unless it was homozygous recessive. So if you've ever seen an albino of any type of species, the albino is when you have no pigment to the eyes, the hair, or the skin color. And it's not very common to happen in nature because it's not a characteristic that helps you to be able to survive. Because if you're albino, I mean, imagine if you're going out hunting, which is the first of the deer that you're going to see. So most of the time in nature, they don't make it past infancy because they're so easily picked off. If you've got no pigment in your skin, then the sun is beating down on you and you get skin cancer or you get sunburns, and it's not easy for these to be able to survive. And so if you see the albino phenotype, then you know that it's homozygous. It's got both of the small letters that combine together in order to make albinoism. And let me see if I can find this picture. So I thought that this was a funny story. I actually Googled albinoism in humans, and I found this really interesting story about this couple. They go to the hospital. She's having a baby. She's had 2 babies before that, and all of a sudden she got an unexpectedly colored baby, as she ended up with a white child. And so they said, how could this possibly have happened? And what they found was that baby had all of mom and dad's DNA. You know, paternity test was done. They came from mom, came from dad, but they had those albino genes lurking in the background. And so all of a sudden, they ended up with a beautiful little white baby. And so it was kind of an interesting, like, human interest story.
Does that mean somewhere along either the mom or the dad's side there were albinos in the family?
Yes. Yeah. It has to have come from somewhere. Yes.
Mom?
Obviously, you put the rest races and all of that that's been around for years.
Hey, Mom.
Hold on.
But I just want to say I thought that was cool.
Yeah, I thought it was.
That the rest of it.
There are actually, there are stories, and these are kind of like wild and crazy stories about women who have 2 uteruses, and they've had a story about a lady that she had had a husband, she got pregnant, and then she had an affair, and she got pregnant a second time because she had a second uterus. She had 1 white baby and 1 black baby. It was unbelievable. I mean, just like such a surprise. Imagine if you went in to have your baby and they were like, "Oh, well, in 6 weeks you're going to have another baby." Like, how do you explain that? They are actually able to explain some of these surprises. Yes, son.
Is this true?
Yes. How about you watch your show? I don't know what's going to come out of his mouth, and so you just have to roll with it. So.
I got a question.
Sure.
So, were her babies considered twins, or no, because they 6
No, because they're 2 separate eggs, so they would be fraternal twins, but not identical twins. Well, you know what? if they were born 6 weeks apart, I don't know that they would be.
Because they would have to be born at the same time. And
Yeah, they'd be brothers or sisters, but I don't know exactly how they. So maybe somebody who's got a laptop is Googling that to see how that worked.
So is it true a woman can give birth to twins, but they can have two separate dads?
Yeah, they can. If you have 2 eggs, and a lot of times when women ovulate, they give off more than 1 egg.
I've just seen it on Maury Povich, not that I.
Yeah, it does sound very Maury Povich-ish. The first time I think I heard about this was on Grey's Anatomy. So,
See?
yep,
That was the show.
yeah. So that was one of the stories along the lines. So let me go back a slide here. So when we're talking about phenotypes versus genotypes, phenotypes being the physical appearance and genotypes being what the genetic code is behind those. The outward appearance is the phenotype, the physical appearance, and the underlying the genotype, or underlying the phenotype is the genotype, the genes, what the alleles say. If they're big A, little a, big A, little a, that's the organism's genetic composition.